What is polymerization and how does it form polymers? Have you ever wondered how everyday materials like plastic bags or rubber bands are made? The answer lies in a fascinating process called polymerization. So, what exactly is polymerization and how does it create polymers? Let's break it down. Polymerization is a chemical process where small molecules, known as monomers, bond together to form long chains or networks called polymers. These polymers are large molecules, often referred to as macromolecules, and they consist of repeating units derived from the monomers. This process is essential for creating many materials we use daily, including plastics, fibers, and rubbers. There are two main types of polymerization: chain polymerization and step polymerization. In chain polymerization, monomers add to a growing chain one at a time. This process is often started by catalysts or reactive species, such as free radicals. A common example is when ethylene monomers join together to form polyethylene, a widely used plastic. The resulting polymer chains can be either linear or branched, which affects their properties like flexibility and strength. On the other hand, step polymerization involves monomers reacting in a stepwise manner, often releasing small molecules like water as byproducts. This method is used to create polymers such as nylon and polyesters, which typically have more rigid, cross-linked structures. The way polymers are formed through polymerization directly influences their structure. This structure can be linear, branched, or cross-linked, and it plays a significant role in determining the material's mechanical, thermal, and chemical properties. For instance, polymers made through chain polymerization usually result in thermoplastics, which can be melted and reshaped. In contrast, step polymerization can produce thermosetting polymers that harden permanently. Understanding polymerization is important when considering material failure and mechanical breakdown. The structure and bonding of a polymer dictate how it reacts to stress, heat, and environmental factors. If there are defects in the polymer chains, or if the wrong type of polymer is used for a specific application, it can lead to premature failure. For example, a polymer with insufficient cross-linking might crack under mechanical load, while one with too much branching could degrade more quickly when exposed to heat. In practical terms, industries depend on controlled polymerization to create materials tailored for specific uses. Automotive parts requiring polymers that can withstand high impact, while electronics need materials with thermal stability. Packaging materials demand flexibility and durability. Failures in these products often trace back to the polymerization process and the resulting polymer structure, making polymerization a key factor in product reliability and lifespan. So, the next time you use a plastic item or wear a synthetic fabric, remember the fascinating process of polymerization that made it all possible.